My name is Lana Chan, and I'm a product marketing manager here at Cadence Design System for its PCI Express verification IP. This Whiteboard Wednesday is the first in a two-part series covering the evolution of PCI Express over the years and what's in store for the future. In this session, I'll be covering the various factors that have driven the advancement of PCI Express to become the de facto interconnect technology that we see in virtually every device out there. In 2003, what is now known as PCI Express Gen 1 was ratified. This was a huge difference from its predecessors, which were parallel bus models, PCI and PCIe. What drove this change from a parallel bus model to a serial model was a demand for larger bandwidth. And the markets that were driving this were high-speed graphics cards for gaming and for workstations, high-speed disks, storage controllers, as well as network devices. At 2.5 gigatransfers per second, PCI Express Gen 1 was widely adopted due to its software backward compatibility with its predecessors. Four years later, PCI Express Gen 2 was released. And once again, it promoted software backward compatibility, a low-cost package, low power, as well as scalability at 5.0 gigatransfers per second. This is also very quickly adopted by enterprise applications that needed the high bandwidth. At the same time, what we were seeing during this time was consumer electronics were also adopting Gen 1, thus widening the market appeal of PCI Express Gen 1 and Gen 2. So we saw embedded systems adopting Gen 1, instrumentation devices, and what's called CPE, consumer premise equipment. In other words, your set-top boxes, your DVR, etc. Fast forward to 2010. We're now seeing a huge amount of smartphone usage. Social media is gaining popularity. And all this means that we're creating a huge amount of content, we're sharing a huge amount of content, but we also want to access this content. And this is having great effects on our network infrastructure. It just simply can't keep up. PCI SIG at that point in time was aiming once again to double the bandwidth from 5 gigatransfers per second to 10 gigatransfers per second. Of course, if we look back now, that was just simply not possible. They did studies at the time, and they noted that for power reasons, as well as signal integrity issues, 10 gigatransfers per second was simply not possible with the existing copper technology. So what instead the community looked at was how could they double the data throughput while using the same technology. They looked at changing the encoding scheme from 8-bit, 10-bit to 128, 130-bit encoding. This reduced the overhead of the encoding, thus effectively increasing the data throughput. So now we could actually meet the requirements for the networks caused by our connectivity. Of course, we're saying, OK, 2010, 4 years later, we should have another generation. It's now 2016, and we're still sitting here with an unratified spec for PCIe Gen 4. What is known is that this is going to be 16 gigatransfers per second. But we have some challenges in order to meet this. What's driving this need for bandwidth? Once again, it's our connectivity. That marathon session on Netflix of your favorite show, huge amount of data going in to the network. All that video that you're creating on your weekend road warrior expedition, it's being dumped onto the cloud, huge amount of data. Your online shopping, people want to actually store that data, analyze it, and monetize it. And yet, our infrastructure PCI Express has become its bottleneck. So in the next session, what I'll be covering is what exactly has the SIG been doing in order to address these needs for this growing data and these needs, and some of the challenges that designers are seeing, and what do we need in order to address those challenges. With that, I look forward to talking to you next week in our next Whiteboard Wednesday session.